Okay, so hopefully you're able to graph these two parts A and B, the functions absolute value. So I'm going to go ahead and do this. Now, you should recognize that for the parent function of an absolute value, our vertex is going to be at 0, 0. And on the right side, on the positive values of x, it's going to have more or less what you would consider, what some of y'all would recognize as a positive slope again. Straight edge is always very useful when doing this. So just do the best you can on the computer. If you're doing it on paper, use your straight edge. And then the other side actually has a -1 slope to come together at that vertex of 0, 0. And so that's the parent function of an absolute value graph. Now, for y equals negative absolute value of x, what we can do is we could actually t-chart this if we wanted to. And so we could t-chart -1, 0, and 1. And of course, if we plug -1 into the absolute value of x, that gives us a +1, but then we end up negating that +1. So that puts us there. 0 is going to give us 0, which gives us the same vertex. And 1 is also going to give us -1. And you can see the trend here that this is actually going to go down at that slope and down at this particular slope, and it creates a reflection over the x-axis. And so that negative value in front of the absolute value is very similar to when we had a negative value in front of the quadratic. It just flips it over the x-axis, the exact same point. So it's got symmetry over the top of this line. So now, as we move into the next part here, what I'd like you to do is I'd like you to do C and D, and when you are dealing with the question what changed, what I really want you to answer is what changed from the parent graph. So that one, that original parent function like this, make the assessment as to how it moved according to that one. So go ahead and take your time and do that right now. Okay, so I've gone ahead and graphed these two graphs on here, and you can see from my red graph, and I'm going to go ahead and highlight this so it's a little easier to see. So if I could draw straight, that would be the parent function of the absolute value. And so you can see from our red graph, what's happened is that this value in here inside the absolute value made the graph actually shift 2 units left. And if you remember from when we did translations in Unit 1, it was a similar effect when we had that value inside the parentheses with the x. It shifted it 2 units to the left. So it's going to have the same effect with the absolute value. Now, you can see here with the 2 in front of the absolute value, it had a similar effect as having a multiple in front of the parentheses in Unit 1 as well. And so what it created was a steeper graph, and so this is a dilation. And so this kind of pinched it in a little bit, made it a little steeper, brought it a little closer to the y-axis. And so instead of going a 1-for-1 type slope, it actually went over 1 and up 2 to create a steeper graph. Now, if I wanted to see what this looked like on the graphing calculator, let me show you where the absolute value button is for that. So if I took the one right here to the 9, next to the 9, the absolute value is down here. It's just the first one in the middle row. So if I click that and I simply plug in x, I can hit enter, and you can see our absolute value function. Now if I wanted to do one with, say, the x plus 2 in it, I could simply hit enter, and you could see the translation that has taken place there. It's slid over 2 to the left. So you can always check your answers on the calculator to just see if you understand what's going on. Okay, so let's just do this one more time. Again, graph the following parts and see if you can assess what has changed in relation to the parent function. And then for part F, maybe if you can recognize the patterns, you could go and do it all in one swoop without using your calculator. Okay, so hopefully you had the opportunity to do part E and F. And what I'm going to show you here is part E is in red. and you can simply see that adding 3 outside of the absolute value bars just simply makes the graph slide up 3 units. So we shifted that up 3 units. Now, hopefully you're starting to recognize that in this particular case, the 2 inside the parentheses is going to shift it 2 to the left. The 3 outside the parentheses, or excuse me, the absolute value bars, are going to make it shift 3 up, and then of course the negative sign is going to make it flip, thus giving us a shift of 2 over 3 up, which gives us our vertex there, and then I'll now know it's going to be upside down. And so that gives us our final graph. And of course you could check all of this on your calculator just to verify your answers.